Okay, let us discuss few problem. You have to write down the product. So let us do one by one. So let us do this problem first and then we'll go for the next problem. So you have been given this problem. So let us rub this one. Let us do this problem. What will be the product? So you have been given R2-butanol. If this react with TsCl, what will be the product you expect? And in this case you have to show the stereochemistry very clearly. Have you written the product or not yet? Done. Do you remember TsCl is what? Para-toluene sulfonyl chloride. So this molecule, if we have something like, so let me draw somewhere. So let me draw here itself. This molecule, if you remember, at position para you have toluene group, and if you have SO2Cl, this is called para-toluene sulfonyl chloride. In short, this is written as TsCl. Did you remember or not? Okay. So what happens on this? Some attacks, opens up, backs, goes. So basically we will have OTS that is attached. So finally, so let me write down the product. In this case, what you will have? You will have this lone pair will attack, Cl will go. So finally we'll have OTS. This is basically a good way to make alcohol a good leaving group. OH is not a good leaving group. If I add TsCl, now it becomes a good leaving group. The important point in this question is this bond has not broken. Simply OH bond has broken. So this means configuration of this carbon will not change. So hydrogen is this side, again hydrogen is this side. So this will go with retention. So this goes with retention. Are you getting? So this reaction go with retention. Now let us do the next one. So if we have something like this, so you have to write down the product again. What will be the product you expect? Now I also give you the mechanism. In this case is SN2. So you have to write down the product considering the configuration also. So let us write down the product. Let me see how many of you are able to do this one. So first write down the reactant and OH minus. In this case you see OTS is a good leaving group. Now OH minus can attack and OTS can leave. That is so simple. Now in this case OH minus will attack from back side. Reaction is given to SN2. So the inversion of configuration will take place. So I will have product is this. So this time we will have inversion of configuration. Are you getting? So this time we will have inversion of configuration. So let me write here. So this will go with inversion. Are you getting or not? So this reaction will go with inversion of configuration. So OH minus is basically attacking from this side. If you attack from this side, this will go slightly this side. This will go slightly this side. So now they are slightly oriented toward this face. So wall, you have a wall. So these three groups are oriented toward this face of the wall. Are you getting or not? Initially these three are facing toward this face of wall. Are you getting? Okay, let us do the next problem. You can do the next one. So let us see in this case what will the product you think. So let us do the two cases. In these two cases, what product you expect? Once again, in one case you have TsCl, you can form OTS. In another case, Cl minus can act as a nucleophile. So in the first case, you see only thing I have changed. In the first case, two questions we have been a open chain compound, I have cyclic compound. So in the first case you will form OTS. In the next case Cl minus will attack and OTS will leave. So you will have something like this, CH3 OTS, and this is Cl will come from the front side. So this is again this is SN2 reaction. This is the inversion of configuration. So this will go via inversion. Are you getting? And this will go via retention. So this is a retention. So let us write. So this will go via retention while this will go via inversion. That is the important point we want to show here. Now let us discuss the next question. You have been given reactant and product. You have to tell me how can I prepare from this compound to this compound. I have been given this compound. I want to convert into this compound. So I have MeSO3OH and I want to convert. OH is converted into OCH3. So you see what we have done is one OH replaced by OCH3. How we can do this one? Any idea? So let me cover the solution part and then you see you have to form this compound. So you see the only white ones. So the white one's the compound. So you have this one and then you have to convert from this to this. How will you do that? You see one thing is very clear. OCH3 minus can attack and something can leave. And OH, I can make OH as a good leaving group. So now right now this OH is not good leaving group. So you see what will the structure of this compound? You can always write. So let me write a structure here itself. So you will have this Me, and if you do SO2OH, so you will have SO2 and then you have OH, something like H2SO4. Now if I can make this OH group as a good leaving group, things are done. If I make OH leaving group, something can attack this OH can go. So what we will do? Same thing. Make the alcohol, so this is alcohol group. Make the alcohol as OTS. In the next step, attack OCH3 minus, or simply you can take alcohol also. Get, are you getting or not? Okay. So let us see the solution. So you can make, either you can treat with PCl5, then you will have Cl, or even you can treat with OTS. So if you treat with PCl5, this will become SOCl to SO2Cl. Now you take alcohol, attack, this Cl goes, make the medium basic slightly, so that this becomes OH minus, O minus H plus. If you take base, this will become O minus H plus, so you will have left H plus, and from here Cl, so you will have basically releasing HCl, and the final product you will get this. Everybody agree or not? Okay, so let us write those who have not written. So let me wait for 1 minute so that everybody can write. And then we will go for the next problem. Have you done this one or not? I think all of you have written. Should I go for the next? Okay, good. So let us come to the next problem. Okay, what you have to do is, you have been given this compound alcohol, and how can you convert from this compound to this compound? So again, conversion kind of thing. So let us try this one, and if you are not able to do, then we will discuss the solution. Okay, so let us see what we can do. I have to remove this OH, and then I have to add, in place of OH, I have to add this group, this whole thing. Are you getting? So what we can do is, first make the OH as a good leaving group, Cl, and then take this as O minus and attack this. So this part, so here you can break. You can take this as a nucleophile and attack on SO2. Are you getting? So what is my task is to make OH as a good leaving group first. So react with SO2Cl, PCl5. In that case you will have SO2Cl, and then you react with O minus CH2CH3. You can take alcohol and medium should be basic. You getting? So let us see the solution. So things are easy. You take PCl5, you will have this. Now treat with this. Use the medium, basic medium. So if you want to do this one, take the basic medium. So medium is basic. Then what will happen? You will have O minus. Basically I have written base here. You can write here itself. So if you take basic medium, this will O minus. This O minus can attack Cl, can go, and HCl will be left out. So finally we will get this compound. So what we are learning is, we are learning if you have OH group in somewhere, you can make as a good leaving group first, and then you can attack a nucleophile, and now nucleophile can change. In this case, this is the nucleophile. In previous case, alcohol was the nucleophile, so you can have a nucleophile as alcohol, you can have Cn minus as a nucleophile, OH is a nucleophile, or if you have OH is a nucleophile, you will get the same compound, so that is not an issue. You can take different basically nucleophile, you can change the product. So this is a good way to change alcohol to another compound, because alcohols are very easily available in the nature, readily available in the nature. You see, most of the you can get the alcohol from most of the plants, and that's why we do the conversion from alcohol. So first what we have to do is first make the good leaving group using the PCl5, and then you add some nucleophilic reagent, so we'll have final compound. Let us discuss the next problem. You have to convert. Now you can do this one. This is the same question, you know, again. So you have been given alcohol. This time there is no need to make this good leaving group, because good leaving group is already there. You have to convert, and then you have to add this product. So how will you go for this? So you have to add this. What can you do? So you simply take the nucleophile of this. Are you getting? And if you take the nucleophile of this, attacks goes. So we'll have a, so let us see the solution. If you have CH3O, OH basic medium, you will have O minus, this can attack, you will get this product. Are you getting or not? So let us copy this one, and then we will go for the next problem. If you have not written, please write this one. If you are understanding, there is no point of writing. Okay, done. Now let us discuss this problem. This is a quite interesting problem. So this compound, when treated with HBr, this gives meso 2,3-dibromobutane. So compound A, so let us call this compound as A. If I treat with, it gives meso product. But at the same time, if I treat this compound is B, so let us call this compound as B. If I treat compound this does not give meso product, this gives 2,3-dibromobutane, that is a plus minus racemic mixture. You see what will happen is, so you are getting 2,3-dibromobutane, so product is 2,3-dibromobutane. So this means, so let us say this is carbon 1, 2, 3 and 4. So at this position you will have a bromine. At this position you will have a bromine. So final product will look something like this. You have 4 carbon. At position number 2 you have a bromo group, and you have a position number 2 you have a bromo group. So 2,3-dibromo. So this is 1, 2, 3, 4. So at position number 2 and 3 you have a dibromo group. So bromo group. So 2,3-dibromobutane. So final product you are getting this. So what you have to do is, if you see, if you take OH and you can attack, if you replace OH and you attack Br, you will get the product. Simple. If you remove OH and attack here Br minus, then you will get the product. Now how will you do that? So let us try to discuss. If I take this compound, HBr is there. If I make OH2 plus carbocation, if I make the carbocation, now Br minus can attack from top as well as from bottom, because carbocation is sp2 hybridized. Now if it is attacking from top and bottom, you will have 2 enantiomer. 2 isomer basically. You can find it out whether basically that will be basically diastereomers, because you see this carbon is a chiral carbon. Now if you are adding here Br, then you will have one Br that is added from top, another Br from bottom. Maybe you will get one is meso, another we will not have meso. Are you getting or not? So in this case, if you make the carbocation, you will not get only one product. You will get 2 product. Because if you attack from top, that is R, let us say, then if you attack from bottom, then that will be S. So let us say this is R, then product will be RR and RS. So you will have 2 diastereomers. You can't have meso, only meso. That is not possibility. So now I cannot say in this case carbocation is intermediate. So you have to think. So let us discuss first. So how will you form this product? How will you form? Any idea? Now see, what we have, if you see here, if you attach Br here and there is a Br, so if you see here, there is a point of symmetry. If you see, back side I have a hydrogen, front side I have a hydrogen. If I have front side CH3, back side CH3, if I extend a line, here I have a Br. If I replace this OH simply and put the Br, I will have a Br here. So we will have a point of symmetry and then I will get the meso product. This means if I remove this OH and simply put the bromine, things are over. Because if I does not change the configuration around this bond, that is, it goes with retention, then I have done. If this bond breaks with retention of configuration, I will add simply OH Br here. If I do that, then there is a point of symmetry. If I simply break this bond with retention of configuration, so let me say, if I break the bond with retention and put Br in place of OH, so I have a point of symmetry. You see this point, then I have a Br. There I will have a Br because I have replaced OH and put the Br with retention of configuration. So I have a Br. So in the same plane, if I extend a line at 180 degree, I am getting this at the same distance. This side I have a Br. At the same time, at this distance I have Br. If I go front side, I have CH3. If I go back side, I have a CH3 at 180 degree. If I extend a line that goes through this point and it's a straight line. Similarly, back side I have hydrogen. On this carbon I have hydrogen. So now I got the idea. If I do retention of configuration, I will get the product. So what should I do so that I get a retention of product, retention of configuration? So this means there must be something like attack should happen from the bottom. Then only I will have retention. Otherwise, if attack happens from the top, I cannot have a retention. Only possibility I have, if attack happens from the bottom, then this bond and the coming bond will be in the same side. Are you getting or not? Or you can say, in this case, in the plane. So this is attacking in the plane from the bottom. This is in the plane, so this bond is in the plane. So bromine minus attacks in the plane also from the bottom. So I need to attack from the bottom. So this is fixed. I have to attack from the bottom. When I can attack from the bottom? So if you remember, if I have a 3-membered ring, then attack always happens from empty side. So if somehow I make a 3-membered ring on the top, I have only one option. Attack will have from bottom. So I have to make, so now I have a hint that I can make a 3-membered ring from the top. If I make 3-membered ring from the top, I can have only one possibility. I have to attack from the bottom. And that is done. So I think are over. Now you have Br. So this Br attacks here. And then I will get a 3-membered ring. So if Br attacks here, this OH2 plus goes. I can make OH2 plus. This OH2 plus goes, I will have a 3-membered ring. And once 3-membered ring is there, I can attack from the bottom. So let us see the solution. So you have here, you first make OH2 plus. This Br attacks here because carbocationic nature. You have a 3-membered cyclic transition state. Not only is this a 3-membered intermediate, cyclic intermediate. Now Br minus can attack here. If it now have two possibilities. If you can attack from here, you can attack from here also. So let us copy this one first, then we'll go for the next. Done. Okay, if done, let us go. Now what can I do is, now this intermediate I have you written or not? Not written. Okay, let us write again. So let me give you 40 seconds more. So those who have written, I can write even more further. Those who have written can write even further. Okay, let me explain now. Then you write. Now this Br minus can attack on this carbon or even this carbon. Br minus has two possibilities. Either it can attack here or it can attack here. Now in this case, you will get both the same product. Let us derive. Let us call this path as a path A, this path as a path B. If it attacks on this carbon, you will have a path A. So let us copy the path A. So what will happen? I will have a bromine from the downside and here I have a bromine from the top side. So let us first write bromine from the downside here and here you have a bromine from the upside. Now see, this bond will go up, this bond will also go slightly up. So I will have hydrogen the back side but top. CH3 also from the front side, but slightly it will go up. So you will have a CH3 here. Now this CH3 will go down and this H will go down and bromine will be here. So bromine is here, CH3H. Let us call this as a product 1. Are you getting? Now if you attack from path B, this time Br will be here on the bottom and this Br of the top. So let us first try the bromine. This Br is in the bottom, this Br in the top. Now this, what will happen? This CH3 will go up, this hydrogen will go up, this CH3 will go up, this hydrogen will go up, this hydrogen, this CH3 will go down. Now you see, if these two compounds are basically same compound, these two are meso form, 1 and 2 are meso. You can see the point of symmetry here. Br, Br, CH3, CH3, HH, same thing here. Br, Br, hydrogen, hydrogen, CH. So these two compounds having a point of symmetry. If you want, you can write the Newman projection formula for this compound also, and then you can prove that these two forms are meso forms. So these two compounds are basically same because there is a point of symmetry. So 1 and 2 are same compound because they have a point of symmetry that we have written here. 1 and 2 are same compound because of point of symmetry. Are you getting? 1 and 2 are same compound because of point of symmetry. So there is a point of symmetry. Have you written? So let us copy this one. This is something called neighboring group participation. What we are doing is, the Br that is adjacent to OH group is participating in the reaction. So this kind of thing is called neighboring group participation. In short, it is called NGP. So you see what the Br that is in the neighbor, what is doing? It's participating in the reaction mechanism. And if this happens, then this reaction goes with retention of configuration. So in this case, you have a neighboring group participation case. So you have to remember the mechanism of how the retention neighboring group participation happens, and then you can write down the product. Okay, let us discuss the B part. So B part is this. If I react this compound with HBr, I get plus minus both. Now things are again simple. First you have to generate OH2 plus. This goes, Br attacks here, you will have a 3-membered ring. Now you have a 2 path, you can attack path A or attack path B. Write on the 2 product, you will find these 2 products are basically not same. They two are different compounds, and that's why we have written plus minus. So I give you 2 minutes time to derive yourself. Not more than 2 minutes. So let us take 2 minute time and then you derive yourself. Make OH2 plus, make a 3-membered cyclic intermediate, then add bromine minus. There will be 2 possible paths, path A, path B. Write on the product from path A, write on the product from path B. You will find these 2 paths are different paths. And you will find these 2 compounds are different compound. So let me wait for some time. Let me relax, you work some. Basically I am looking for a trick so that I can relax more. And this is all about the relaxing part. You can see this is a better way to learn. If you are a good student, you can learn a lot from these e-lectures. Basically, if this is done, you can take your own time, you can learn a lot. I don't know why people have not, up to this point of time, they have not applied this kind of concept. This kind of concept is very, very useful. And for most importantly for those students who are sometime not coming to the class, sometime they are not able to attend the class due to some reason, or even if you don't feel comfortable in the class, you can take your own time, relax yourself. So this is a good way to learn. So how many of you derived the product? So let us derive the product. Let me wait for some more time. Okay, let us discuss the solution for this question. Now you will have, if you make OH2 plus, leave OH2 plus, you will have a 3-membered cyclic transition state. You have a path A, path B, Br minus cut and attack on path A and path B. So let us copy this one and then we will go for the next part. Okay, so if you follow the path A, that is the attack on this carbon, so bromine you will have downside, and this carbon you will have bromine upside. So you will have bromine downside, this side bromine upside. Now you see, this H will go down, this CH3 will go down, so H will go down, CH3 will go down here. H will go up, CH3 will go up, so H will go up, CH3 will go up. Now if you follow path B, now this time if you follow path B, this side bromine will be down, and this side bromine will be up. So this side bromine is down, bromine is up. If you follow the same steps, you will find. Now these two compounds, you can make the feature projection formula yourself, or Newman projection formula yourself, and you can verify yourself that these two compounds are different compounds. So what is your task is, you can make the feature projection formula, and then you can see these two compounds are different compound. Other way, you can find what is the configuration of this carbon and this carbon. Similarly, this carbon and this carbon. If the configurations are not same, so for let us say this is carbon number 2, this is carbon number 3, this is carbon 2, carbon 3. If the configurations are not same, you can say these two compounds are different compound. Are you getting? Basically, these two will be enantiomer to each other. You can verify yourself. So 3 and 4 will be enantiomer to each other. So this is called neighboring group participation. So you see 3 and 4 are enantiomer to each other. One can verify by finding configuration, or one can find using the feature projection formula. And this concept which we have discussed is called neighboring group participation. So this is all about the neighboring group participation. We'll go for the next problem. Okay, let us go for the next problem.